Mars is the fourth planet from the Sun and has a distinct rusty red appearance and two unusual moons. The red planet is a cold, desert world within our solar system. It has a very thin atmosphere, but the dusty, lifeless planet is far from dull. Phenomenal dust storms can grow so large they engulf the entire planet. Temperatures can get so cold that carbon dioxide in the atmosphere condenses directly into snow or frost, and Mars quakes. A Mars version of an earthquake regularly shakes things up. Therefore, it is no surprise that this little red rock continues to intrigue scientists and is one of the most explored bodies in the solar system. Why is Mars called the red planet? The bright rust color Mars is known for is due to iron-rich minerals in its regolith, the loose dust and rock covering its surface. Earth's soil is a kind of regolith, too, albeit one loaded with organic content. According to NASA, the iron minerals oxidize, or rust, causing the soil to look red. 2 facts about Mars. Mars is also known as the red planet. This is because Mars is covered in soil, rock, and dust made from iron oxide, which gives the surface a red rusty color. Mars is smaller than Earth with a diameter of 4,217 miles. This makes it the second smallest planet in our solar system. A day on Mars lasts 24 hours and 37 minutes. 1 year on Mars is 687 days long. That's 1.9 Earth years. This is because Mars is further away from the Sun, so it takes longer to orbit it. Mars has very weak gravity. Gravity on Mars is 37% less than on Earth. This means that on Mars you could jump 3x higher than on Earth. Mars has a thin atmosphere made from 95.9% carbon dioxide and 2.7% nitrogen. The atmosphere is so thin that it's not thick enough to trap the Sun's heat, so it is very cold, ranging from 100 in winter to 20 in summer. Mars experiences violent dust storms powered by the Sun, which can last for months. The dust storms can completely cover the planet and continually change Mars' surface. Mars is home to Olympus Mons, a dormant volcano and the largest volcano and highest mountain in our solar system. It is 16 miles high and 600 kilometers across the base, making it 3x the height of Mount Everest. As it's so close to Earth, Mars is the planet that humans will most likely step foot on and explore first. There is no evidence of life on Mars. However, it is the planet with the best conditions to support life, and scientists believe there is potential for life under the surface of Mars because they recently found water ice just under the surface. Mars is 4,220 miles in diameter, far smaller than Earth, which is 7,926 miles wide. The red planet is about 10% as massive as our home world, with a gravitational pull 38% as strong. A 100-pound person here on Earth would weigh just 38 pounds on Mars, but their mass would be the same on both planets. 3 million Argentine pesos, moons. The 2 moons of Mars, Phobos and Deimos, were discovered by American astronomer Asaph Hall over the course of a week in 1877. Hall had almost given up his search for a moon of Mars, but his wife, Angelina, urged him on. He discovered Deimos the next night, and Phobos 6 days after that. He named the moons after the sons of the Greek war god Ares. Phobos means fear, while Deimos means rout. Both Phobos and Deimos are apparently made of carbon-rich rock mixed with ice and are covered in dust and loose rocks. They are tiny next to Earth's moon, and are irregularly shaped, since they lack enough gravity to pull themselves into a more circular form. The widest Phobos gets is about 17 miles, 27 kilometers, and the widest Deimos gets is roughly 9 miles. Earth's moon is 2,159 miles wide. 4 million Argentine pesos as seen from Earth. To the Earth-based telescopic observer, the Martian surface outside the polar caps is characterized by red ochre-colored bright areas on which dark markings appear superimposed. In the past, the bright areas were referred to as deserts, and the majority of large dark areas were originally called Maria, Latin, oceans, or seas, singular mare, in the belief that they were covered by expanses of water. No topography can be seen from Earth-based telescopes. What is observed are variations in the brightness of the surface or changes in the opacity of the atmosphere. 5. Exploring Mars responsibly. If we send humans to the surface of Mars, we must do so responsibly. Throughout history, humans have devastated ecosystems in the act of exploration, both accidentally and intentionally. The National Academies of Sciences, Engineering, and Medicine laid the groundwork for planetary protection policies that balance responsibility with the desire to explore. The Planetary Society advocates for these recommendations and supports scientifically motivated guidelines for responsible planetary protection. 6. What is Mars made of? The red planet is rocky, much like Earth. It has a diameter of roughly 4,222 miles, about half of Earth's diameter. Mars' crust is 6 to 30 miles thick and is composed mainly of iron, magnesium, aluminum, calcium and potassium. Below that is a rocky mantle 770 to 1,170 miles thick, which surrounds a dense core that's made of iron, nickel and sulfur and has a radius of 930 to 1,300 miles. 7. Is there life on Mars? NASA scientists believe that life may have once thrived on Mars, as there is ample evidence that the planet used to be much warmer and wetter billions of years ago. Whether there is anything alive today on Mars is an open question. NASA's Curiosity rover detected methane, a potential indicator of microbial activity, expelled from the ground in the region known as Gale Crater. The probe also spotted intriguing evidence of organic compounds in the Martian soil, though what that means isn't entirely clear. The mystery of life's origins on Earth has long puzzled scientists, but a recent discovery on Mars might be shedding new light on this profound question, while also inching closer to finding life on Mars. According to Rapin, this is the first tangible evidence we've seen that the ancient climate of Mars had such regular, Earth-like wet-dry cycles. He emphasized the importance of this discovery, adding, "But even more important is that wet-dry cycles are helpful, maybe even required, for the molecular evolution that could lead to life. The conditions supporting life are intricate. While water is vital, equilibrium is necessary. The right balance can promote the essential chemical reactions leading to life, controlling the concentration of chemicals feeding the formation of polymers like nucleic acids, considered as life's building blocks. 8 million Argentine pesos is windy and watery. The primary driver of modern Martian geology is its atmosphere, which is mostly made of carbon dioxide, nitrogen, and argon. By Earth standards, the air is preposterously thin. Air pressure atop Mount Everest is about 50 times higher than it is at the Martian surface. Despite the thin air, Martian breezes can gust up to 60 miles an hour, kicking up dust that fuels huge dust storms and massive fields of alien sand dunes. Once upon a time, though, wind and water flowed across the red planet. Robotic rovers have found clear evidence that billions of years ago, lakes and rivers of liquid water coursed across the red planet's surface. This means that at some point in the distant past, Mars's atmosphere was sufficiently dense and retained enough heat for water to remain liquid on the red planet's surface. Though water ice abounds under the Martian surface and in its polar ice caps, there are no large bodies of liquid water on the surface there today.